Welcome to KMS CAD Design YouTube channel. This is mainly made for engineers, especially mechanical engineers. Let us start with the new uh, valve body designs in this video. So just log into your SolidWorks software and just create a new file, means part designs, and then select the orientation, which plane you want to create the sketch. So I have selected the front plane and drawn a center line and applying some constraints on the sketch. First in coincidence given, and then applying the constraints called the vertical. And the next I'm just drawing the sketch for the valve body. So with respect to origin, I'm starting the valve body sketch profile. And while drawing sketch itself, you can maintain the constraints, whether it is horizontal or vertical. So it will automatically takes. And also later you can edit the constraint also, even if it is angular line or a slanted line, you can apply the constraints. So now I made a closed profile, and just select the two endpoints and make it as a coincident. So now it looks like a closed profile. Please ensure it should be a closed profile for making a revolve object. So I'm applying a dimension to the flange thickness. Just select the line as well as the center line. So if you move towards the left, it will be considering as a diametrical. If you place it in right hand side, it will be considered like a radial dimension. So I applied the flange thickness, and next applying the thickness of that means the valve body shoulder, and then defining the shoulders OD dimension, and then the major valve body, what is the height of that valve body. So the profile got modified, so you can drag and modify the profile. Click on dimension and select the entity. It is all the smart dimension. So select the entity and apply the dimension. So here I have made the flange thickness of 40 mm thickness. Maintain uniform, means the bottom as well as the top flange having the same thickness as well as the same diameter. Maintain with the 225 mm OD, and the body dimension I have defined with 350, I guess, and overall it comes to 440. Since all the dimensions are defined, so it is showing as a over defined dimension, so it will be showing as a gray color dimension. And ensure the before executing the sketch, ensure the sketch is fully defined or not. Okay, that is mandatory. Otherwise, the sketch will get moved. Suppose if we modify, means if you just drag the sketch, it will get modified. So sketch should be fully defined condition. And then apply, select the revolve command, and with respect to axis, it is created the valve body, and you can keep the orientation. I just made it as a front orientation, and just made the section how it looks like internal. So it is completely filled with material, and then I'm just creating a shell, just maintaining 12.5 wall thickness uniformly inside. So it is a 4-inch valve body. So the inlet size is around 100 So apply once again the dimension, smart dimension, select the entity and the center line. So it will show us a diametrical dimension and you can modify. And applying the wall thickness, so you can select the sketch as well as the edge of the component. So 12.5 define. And here also I am maintaining the same wall thickness. Sorry, it is not our thickness, unwanted dimensions. So create our just go to smart dimension once again. Yes. Bottom applied with the diametrical dimension 100 and then applying the remaining two line with 12.5 uniform thickness. Select that entity line and then the body edge. So you can maintain the uniform wall thickness either by maintaining a diametrical dimension or else by just apply the wall thickness value directly. Here I have drawn the profile I have made with my own dimensions. So you can refer any mechanical design book for creating some complex product designs. So this is my own design, just applying with my own dimensions over here. And hit the OK button, then select the revolve cut. So it is revolved with respect to an axis 360 degree. So now you can take this section as well as you can ensure the wall thickness is maintained uniformly 12.5 around the body. So now I'm just creating one more flange towards the right hand side. So I'm creating a reference plane from right plane. So the plane is created. With respect to the plane, I am creating a sketch profile, a circular flange I am creating with a diametrical dimension 225 and ensure the sketch is fully defined. It will turn as a black color. Okay, so select that entity either by applying through dimension. You can make it fully defined, or else you can apply the constraints. Means one dimension is required and the center point should be aligned along with the axis. The valve is body center line. And the thickness I am maintaining the same thing, 40 mm. again I'm just making like a pipe component from the back side of the flange towards a body. So using the extrude command only, so I'm just creating a sketch and select both entity, means circular edge as well as this sketch, and make it as a concentric constraint so that it will align automatically with respect to the center of the selected entity. Okay, so sketch is fully defined with our defined values. So now select that sketch and hit the extrude command, and we have plenty of options. So here I'm just selecting up to surface, select the surface, and okay, so now it is merged along with the body. So I'm just creating the nozzle for this flange with the same 100 mm 4-inch inlet. Apply the constraints called concentricity, means concentric, and 4-inch approximately 100 mm. So it's a extrude cut. By blind method, and just applying the how much you want to cut that body. Okay, so now the hole is made. So take the cross section and verify. So we have maintained the uniform wall thickness, entire body except the flange thickness. So now I'm just by default the configuration is created. So I'm applying the fillet around the edges by selecting faces, and all the flanges I'm applying the same method. Select the faces of all the 3 flanges, top as well as bottom, and then define the radius. I think I applied with 2 mm radius, and then applying some bigger value fillet, the body sharp edges, so all the sharp edges must be defined either with a fillet or else chamfer. Means wherever it is required, we must follow the fillet, apply the fillet, and then applying that internal sharp edges. Select the both edges, and one more edges I'm applying fillet value. So now the valve body design, it is over. So I'm selecting the entire feature and putting into one folder, creating a folder called defining with casting as the name of the folder. And next I'm planning to create a machining configuration So the third icon is called creating configuration. So create a configuration and defining the name of the configuration called machining. So hit OK button and then go to the design tree, model tree. Create the machining configuration. So now I'm just doing a face machining operation for all the flanges. So I'm just creating a closed profile, rectangular profile for every flange face. So 3 mm machining I'm doing for all the flange faces. So minimum wall thickness to be maintained for machining operations. So I'm just removing the material from the flange by 3 mm. Ensure the profile should be completely closed and fully defined. Fully defined means it will turn as a black color. So similarly over here, right hand side, apply 3 mm thickness, means material removal we are doing. So 3 mm thickness, and then the remaining profile you can define your own dimension. To make fully defined, I'm just giving one more dimension from the flange face, and the bottom also I'm applying 3 mm thickness to be trimmed from the flange face, and the remaining profile you can apply your own dimension. Okay, so I'm defined here with the dimension. Either you can apply symmetric constraint also. With respect to center line, you can select both entities and the center line apply symmetric constraint instead of giving dimension. So now extrude cut. So all the 3 profiles are selected, and then define the how much you want to extrude, the depth of the material you have defined. So now the face, entire thing is removed. So next the drilling operation carrying out with proper profiles PCD of the hole, means apply the concentric constraint by selecting the edges as well as the circular profile, and then define with the values what is the PCD, and ensure the first hole it should be defined with respect to the axis at angular condition. So I'm just making 8 number of holes. So the first hole position with respect to center line angular dimension 22.5 degree, and hole size ensure it should be with respect to center. So now this whole dimension we have maintained. And make it as a construction for the PCD imaginary sketch, and then extrude cut. Blind method, I'm just applying 50 mm thickness because I know the flange thickness is 40 mm. You can choose a multiple option up to face or up to next. You can try, many options are there in that command. So now I'm just making a circular pattern, 8 number of holes. Select the feature and then how many number of holes you require, and select the edge, so it will create automatically. Similarly, I'm making the same method on this flange with the same PCD. And so same method you can make a, means I'm drawing the same means defining the hole. The first hole, it should be with respect to the center line. The angular dimension should be applied 22.5 degree, because I'm maintaining the same number of holes in all the 3 flanges, because it will be connected in the pipeline. So it will be having the same designs on all the 3 flanges. (20 mm). Applied the hole by extrude cut method. Extrude cut. Select the profile and then extrude cut. Now make a circular pattern. Select the feature and how many number of holes, equally spacing options, and select the entity so that it will create number of holes equally placed on the face. So now I'm just going to mirror those holes to the bottom flange. So I'm creating a reference plane from the face is making 100 mm. So now the reference plane is created. I'm just going to mirror the circular pattern hole. Yes, now it is created. So all these features are related to the missing configurations. So I am going to select all the feature. I am going to place it in one folder called machining. So just ensure how the component looks inside. Select all the features and then create a folder and name it with machining. So 2 configurations are created. One is the casting one, so it does not have any machined holes, machining operations. All the features are suppressed by automatically, and then you switch over to the next configuration, machining, then it will show all the machine features. So just double click on that configuration so you can switch over casting or machining. So file, save, and define the name of the file. So I am defining with the wall body 4". So that's it from today presentation. So next, based on your comment, I'm plan to prepare the next 3D designs using a SolidWorks software only. So thanks for watching. Thanks for having patience to listen from scratch start till the end. Thank you everyone. So I hope this will be very useful for the beginners, especially the freshers.